All right, so we discussed basic stuff like um, variables, arrays, lists, for loops, for each loops, while if statements. Let me show you. Let's go into the Unity stuff, but first I like to explain functions before we get into the Unity stuff. And I believe you are from Japan, right?
No, I'm not from Japan, but I'm somewhere from Southeast Asia.
Oh, okay, okay. Uh, sorry, sorry about that. But uh, probably it's a bit late for you. I assume it's a couple of hours of difference. Uh,
Yeah.
all right. So I'll try my best to go through this as fast as possible. Um, so first, let's discuss functions. But before that, I want to show you something. So let's say we have a while loop, for example, with some condition, and we want to stop it at some point, right? We make a if statement with some other condition. I just use this word, but it doesn't give me errors. Um, there is something called break. This line of code here, break, and what this does is it will leave a loop, the loop that it is inside. Okay, so if you say this, then it will stop this loop, and it will go with the code further. But let's say we have a while with some condition. Okay, let me actually copy paste this. Okay, but then uh, we have a while inside the while, right? Uh, then this break here will stop the first while, okay? And it actually, if you click it, it will show you which while it breaks, right? So if you want to exit the other while, you have to do it inside there. So let's say some condition, whatever, and then break. So you see this break here is for this while, okay? So basically, uh, it will leave the while that it is inside of. Okay, that's useful. Now let's get into functions. So functions are basically you give name to some code. That's what a function is. And there are so if I say void from function like that, and you have to add these parentheses, and inside here you can add parameters. No, this is one. So you can have multiple of whatever, right? Um, and then in here we have some code, right? So that's a void function. It just executes some code, but it can also return something. So, for example, let's say it's a int, type int. So that means basically you do some code here, so some code, right? And then you have to return a variable of type int. Okay, so whatever the type is, you have to return a variable of that type. So at the end you have to say return, and then you have to return a value of that type. But you see it because it's nothing inside this. I have to give it a value. So you either have a void function, so which just executes code, or you have a function that returns something. So and for that you specify which type of value you have to return. And usually this is for when you calculate something and you want to return a value or something. But this can be in Unity. This can be not only this, but also the variables can be components, can be a whole game object, can be many things. And we'll get into that. Those are functions. Uh, so let's get into the Unity stuff. If it's okay with you, I will go through the controllers from this scene. So the controls for the player, is that okay with you?
Yes.
Okay. Okay. This is the script for the player, and here are the variables that we need. You can see here this is the rigid body 2D. Like I said, this is gives physics to the object, and I named it RB for short rigid body. We have the animator because we want to change the animations. We want to manage those, and the sprite renderer. This is both for the trail effect. We need that for the trail effect, and also to flip it. We want to flip the player so it looks towards the direction in which it's moving. And I make them private because we don't want to see them in the inspector, and also we do not need to use them in another script. Then we have here a float, so a whole number. I named it horizontal axis because this float here will give us the direction in which the player is moving. And then we have a move speed, a value for the move speed, a value for the jump force, so how high to jump. Jump count here, we use this to control the jump. So we limit this to a maximum number of jumps. So here we count, and this is the max value, max jump count, an integer. And you see this here, this serialized field here. When you have a private variable like this, and you want to show it in the inspector, you use this serialized field to show it in the inspector. Okay. And then this is the trail effect. You can also have variables that are scripts, right? So this is a script that I created, and this is the trail effect script, and I have it here because sometimes I press a key to enable it. So let's go into the void start. This happens at the start of the game, not the start of the game, but the beginning of the existence of the object that has the script. Which in this case it is the start of the scene. So I get the components because here I created the variables, but they're empty, they have nothing inside. So this function here, get component, this will get you a component from the current object that has the script. And I do this for every component that I need, the rigid body, animator, sprite renderer, and also the trail effect in this case. And I give the jump count 0, so we start counting from 0. And for this is a bit weird for you, I think, because I created functions for controlling fixed update. In update here, everything you put in here, it will happen every frame. And I don't mean visual frames. I mean like this happens every couple of milliseconds. This happens very fast. Okay.
Yeah.
So the reason why I have one function for update and one for fixed update is because I do physics every frame, and if you do that, you cannot do it in update. You have to do it in fixed update. Because I don't know the exact explanation, but this is better for the physics. I'm not sure why. That's just the way it is. If you put it in the update, if you do physics in update, it will be laggy. Okay. So I have a function for the update. So in here, like I said, this variable gives us the direction in which the player is moving. So I say it is equal to input get axis horizontal. So this will give us the direction. So if you press A, it actually says here, this here. So if you press A, it is -1. If you press D, it is 1. And if you press nothing, it's 0. And it also works for the arrow keys, right? So I get the direction, and then I check here. You see if that is different than 0. So in other words, if the player is moving, then we enable the animation. So we say animator, so the animator component, set bool, so the parameter from the animator. Let me show you. So this here that are used for the transitions. So we make that the bool is running, code is running. We make it true because now we are moving. And we flip here, we flip the sprite. So we check if if you're moving towards the right side and it is not flipped correctly, then we flip it, and then we do the same for the if you are moving the other way, if you move towards the left side, we do the same. So here basically we enable the animation and we flip it towards the right direction. But then we have else. So if we are not moving, then we just disable the animation by making that parameter is running. We make it false, and it will automatically transition because of these transitions. So these are also. And then for the jump, we check first if we can jump. So if we haven't reached the maximum amount of jumps, first we check if we can jump, and here we check for input. So if W is pressed, and now I will explain what this is. So input get key down means it happens once when you press down the key, but you can also have just get key without down. Okay, like this, and that means it will happen while you press W. So this happens once, and the other one happens while you press it continuously. And you also have a get key up like this. This is when you release the key. It happens once. Okay, so we check if we press the jump key, and if we do, then here this is the rigid body RB. And then that means we select a property from that. So we select the linear velocity y, meaning the speed and the direction. No, sorry, just the speed on the y axis. And you see here I wrote for other versions of Unity, for older versions, you have to modify the whole vector 2 velocity. But in this version, you can just modify it on one axis. So I say it's equal to the jump force to apply the jump force. And then we increase the jump count by 1. So we count that we jump. And then here we enable the, not enable, but we update that parameter from the animator, the jump count. And you notice that we say set integer because it is an int, and here we say set bool because it is a bool. So we update that to enable the animation. And this is just for the trail effect. So if you press space, then you enable that trail effect script. So that's for the update. But in the update fixed, in the controls, in the fixed update, we just apply the physics for the x-axis. So linear velocity x, so the movement on the x-axis, it's move speed, which this is a float, and times the direction, which is also a float, but this is either -1, 0, or 1. Okay, so we do this every frame. We keep it moving. And the cool thing is it will stop when you're not moving because this will be 0 if you're not moving. And here this what this is a function used for collisions. So whatever you put inside here will happen if you collide with something. Because you know this player has the box collider. So we check if this collided with something, and that information it's in this parameter. So this will give us the object that we collided with. Okay, so we check if the object that we collided with it's a platform. So compare tag again. The tag is, you see here in the inspector, is a category, and we have that for our platform here. We made it, we called it, we gave it the tag platform. So we check if it is platform, and then if it is platform, we reset the jump. So we make the count 0, and we also update that animator to disable, in this case, the animation. So is this clear until now?
Yeah, I think I understand most of it, but what does the last part do? the part where you like animator dot set integer jump.
Yes, yes. Like I said, let me show you. So this player has the animator controller here. So these are the animations, right? And we want to make transitions automatically from one animation to another. So transitions are these lines. And we in here we have these parameters. You see, jump count. So this is an integer and is running. It's a bool, and we use this to make the transitions. So these transitions have conditions. You see here in the bottom right corner. And so here, what this does here, okay, it sets the integer, and here we give it the name. And then this here is the variable jump count from this script, where we count how many times we jumped. Is that clear? So we just update that parameter in the animator here to enable or disable the animations. Does that make sense?
Yeah, I think so.
Okay. Let's see. I will go into yeah, I'll just explain this, and then I will go into some important things in Unity. Let me explain how the trail effect works, but first let me show it to you. So what this does is it creates it spawns some sprites, you see, which are exactly the same as the character, and then they fade. Okay. So how does this work? Okay, let's see. So first of all, we have to have that. We have a trail prefab here. Let me show. Is this? I think this is it. So we have an object here that we spawn with a sprite renderer, and then this script, and we spawn this. So these are the sprites that fade from the trail, and then we have a script on them that will fade the transparency. That's what the script does. So we spawn this, and then we fade the transparency, and after the transparency is 0, then we delete it. So let's look at that script first. So this is on the sprites. So we get the sprite renderer because we want to put this inside this the sprites from the player. Let's see. Wait, I'm a little bit confused. Oh, okay, nice. So here we have a float fade duration. So how long does the fade? How long the fade effect lasts? And in the start function, we put the sprite renderer from this object into this variable because we want to change it later, the sprite inside the sprite renderer. And here is the interesting thing and very useful, very important, the coroutines. So this is a coroutine, not a normal function. And you use this when you have processes that take time. Okay, so you say this here, I enumerator, this means coroutine, and then this is the name of the coroutine. And in here, we have a special for, very special, because you see, we do not count, it's a float. We do not count steps here. We count time in this for. So we start from 0 to 1. And then we add the time, delta time, to that float. And this is the time difference between frames. So in other words, we count the time, the real time here. And then if you just look at this without the division here, this will last 1 second. But then I divide that time to fade duration so that this for lasts that amount of seconds. So this here, this variable, fade duration, amount of seconds. So in this for, we select the color property from the sprite renderer, and we cannot, unfortunately, we cannot modify the transparency directly, so we have to create a color here. So this is, if you do not know, this is the red, green, and blue value, and then this is at the end is the transparency. Okay, so we keep the color the same, which is white, and then here for the transparency, we use this function mathfblur, also very useful. So this here selects a value from a starting point, which in this case is 1, so a value between a starting and an ending point. So this is the starting point, this is the ending point, and this represents where between those points we select the value, right? And this is a value between 0 and 1, 0 meaning the beginning and 1 meaning the end value. Okay, so the starting value is 1 because that's completely visible, and then alpha 0 means completely invisible, and this here means wait 1 frame. So this for starts, this happens 1 frame, and it keeps going until we reach the time limit. But there's also another way to wait seconds. You can say return wait for seconds. Okay, and then you specify, for example, 1 second. So you can also, in a coroutine, you can also wait seconds if you need to. Okay, and then at the end we delete that object because we no longer need it, and we don't want to keep in the memory those sprites, those objects. So, but this here can be used for many things. You can use, for example, you can move one object from a position to another. You can rotate one object from one starting value to another. You can do many things. So I will actually send you this here because it's useful for many things. So is this clear? Do you understand how this works? This for here?
Oh, yeah. Yes, I think so. I think I understand most of it.
Okay. But the important thing is just that a coroutine is for processes that take time. And unlike functions, you have to say start coroutine. And also another useful thing, you can save coroutines like this. The coroutine gives the name. Okay, like that. And then when you start it, you can actually save it in a variable like this, you see. And this is useful because sometimes you want to stop a coroutine while it's running, right? And to do that, you say stop coroutine, and then you specify which one, which is in this variable of type coroutine, you see, and you can stop it while it's running. Okay, and if for some reason you want to stop it from inside it, you just say, I believe, if I'm not mistaken, yield break. Yeah, you say yield break and it will stop the coroutine. That's another way. Okay, so that this here is the image that fades, and we spawn those. And here is the trail effect script. So with this, we spawn the sprites that fade. So obviously we have a counter for how often we spawn those here, and we have a counter for how long the effect lasts. So we need that prefab, so the object with that we saved with just a sprite renderer and the script that fades it. So this is a variable of type game object, and you see it is public because if we go to the player, we need to add that object to our script. So you see here is the trail effect. You see trail prefab, we had to add that prefab, and prefabs again are objects that we save. Okay, and then the sprite renderer we need it from the player because we want to give the sprites to those images that fade. We want to get that from our player. So in the start function, obviously we get the sprite renderer with the get component from the player, because this script you see it's also on the player. And in the update here, so we count the time in this, and if we reach so every couple of I don't know what the value is, let me see. So every 0.15 seconds we spawn an object with that sprite. So first we reset the counter so we can count again. And this is a weird line here. I know it looks complicated, but it isn't. So first, let me show you what this is. This here means instantiate means spawn. So we spawn. And first you have to specify which object. So we want the trail prefab. And then where we want to spawn it. We want to spawn it at the player position, so transform position. So this is the transform which I showed you. It is for every object that is not user interface, which gives the position, rotation, and size. So we get the transform of the player and then the position. And then this here means rotation 0, 0, 0. That's what this is, the rotation that we want to spawn the object with. But we can also get the sprite render from it while we spawn it. So we spawn it first, and then we get the sprite render component of that prefab, which is the sprite that fades, and we save it in a variable here. And then we change the sprite of the player. That's what is here. So this here is the sprite renderer that we spawned. This is the image from that, and we put the sprite from the player inside. And here we also maintain the flip. So in other words, in which direction the sprite is looking. So we maintain that as well here from the sprite renderer of the player. So that's for spawning the images, and this here is for how long this effect will last. In this case, it's 2 seconds. And when we reach 2 seconds, we just disable. So this here means this script, and enable means if it is active, and we say it's false, so we disable it. And on enable, this happens when you enable the script, or actually, I'm not sure is this. Yes, not the script, the object apparently. Well, okay, I think I might have made. I think I made a mistake here, but we reset those counters here. Yeah, that's a mistake actually. Okay, that doesn't matter. Okay, so let me show you another thing. Let me see. Let's look at UI for a second. So you see when I play this scene, there's the loading scene here. Okay. This loading that fades, you see. So let's look into that. 1 second. To use UI, you can use it in 2 ways. So first you need the canvas, like this. So you click and just go to UI and then create it. I already have it here. And you see here it says render mode, screen space overlay. So this means this UI in this canvas, it's above everything. Okay, but you can also put it in world space if you want. So you would use, so it's like an object in the scene, not above everything. And you would do this. You do this for example, on HP bar over the player or something like that. So you can also put it in world space if you want to. And then in this case, where it says UI scale mode here, because the game is for multiple resolutions. We have to scale with screen size, so it adapts to different resolutions. And I just put full HD here. And let's see some objects that are UI. One is image, so just an image. You can use sprites in here. Yeah, not much about this. This is the black image in this in the scene, and you can, in this case, it's not necessary, but you can preserve aspect so that an image has the same how do I say, proportions, like in the original image. Okay, and another thing, you see this here in the corner, this stuff, these arrows. These are anchors, so these help you stretch. You decide how do you want to stretch your UI with this. I'm not an expert at this, but you can decide how to stretch it with those. And this is the text, Text Mesh Pro, TMP. This is for text. You can have fonts, alignments, like in Word. This is basically like in Windows, Microsoft Word. Basically, kind of the same properties here. And an important thing in this case, how do we fade it? Well, we have a canvas group, and this lets us modify the transparency of all the children objects. You see, I can just modify the alpha of all of them, so I don't have to do it separately for each one. And I have a script for that in here. Let's see. And you see, I use a coroutine exactly the same as the one from the player from the trail effect. So we have a for that counts time, and we modify the alpha with the $, so from a starting position to an ending position. And the reason I make it 0 at the end is because you see this t goes from 0 smaller than 1, so it's not, it actually does not reach 1. It's very close to 1, but it is not 1 at the end. So I just set it to 0, the ending value. Okay, so I think that's it with this project, but I want to show you how to raycast and maybe particle effects if you have time. So please let me know, do you have time for a little more? So I can leave. Okay. So let's go into a 3D project. I'm thinking what else I can show you. I'm not sure. Let's see. Raycast, I don't know what else I can do. We'll look at some raycast. Okay. So while this loads, what is a raycast? So we discussed colliders, which can be used for physics collisions or detect stuff. But a raycast is like a collider in the shape of a line that lasts one frame, and it's used for detection usually. And I'll show you how to do that in this project. And you can use it in 2D also, but there are two separate functions. You have a raycast 2D and raycast 3D. So here we look at how to raycast 3D. Okay. Let me see the script. Yes. So this project here is like a demo for a game for persons that cannot see. So in here, when you click an object, it tells you what object it is. And to do that, we use raycast to detect objects from the center of the view, which is, in this case, let me show you actually. So I'm not sure how to explain it, camera in 2D, but in here we make it a child of an object, so it moves with the player. Sorry, make it child of the player, so we can move it with the player. Okay. So first, let me show you what this is.
Platform.
You see, I click
Platform.
and it tells you what it is.
Wall. Platform. Wall.
So how does this work?
Nothing. Nothing. Nothing.
Okay. So I have a function here. Wait, no. It's actually not that simple. One second. Yes. So this is how to create a raycast. Actually, there are multiple ways, but this is one of them. One is first we create an array, so this will hold the information. In this case, the starting position. So where do we spawn this array, and the direction which is looking. In this case, it's the camera and the forward of that camera. So basically the center of the screen, basically. Sorry, the center of the view, basically. And here this is a little bit complicated, but make an if statement in which we create the ray. We make the raycast, so we create the ray here. Physics raycast, so we create it. With that information, so the starting point and the direction, and then the information resulted from this will be saved in this variable hit info of type raycast hit. So this here means after we create it, we put the information, so out this raycast hit variable, and then this is how the length of that ray, so how long it is, and then the last variable is a layer mask, and we talked about physics layers. So with this, you basically select a certain physics layer, so you decide which layers this ray will target. And it is inside this if because this returns either true or false. So if this returns false, it means we did not hit anything with the raycast. And if it's true, then it means we hit something. And in here I do some, I check if it is nothing or it's actually something, and change the color of the UI. But that's not important. This is how to create it. Does it make sense? Because I know it's a bit complicated, the syntax, but it doesn't really matter because you can find this on the internet in the documentation. You just need to know that it exists, right? So you can you have everything you need to start making use. I'm looking, maybe I can show something else, but I don't think I have more to show, unfortunately. Let's look at maybe how to change scenes and how to use sound effects, okay? Is that okay?
Yes.
Okay,
I think it's okay.
did you understand the raycast, the idea of the raycast?
But yeah, I understand its purpose. I think.
All right, well, let me show you how to. This is very simple actually. So to change scenes, you just have to first use this here. So you say using Unity Engine Scene Management, and then you just say Scene Manager load scene and the name of the scene, and this here changes scenes instantly. Yeah, I think I'll stop here because it's not really that hard to use sound effects. You can find that on the internet. Now, I guess if you have questions or anything you would like to know specifically.
Let me think of something. I think I thought of a question, but I forgot about it.
All right, no problem. Well, I guess that's it. And yeah, you can ask me in private if you have a specific questions. Specific question. Okay.
Okay.
All right, that's it. Thank you. Because I actually recorded it for everyone.